So here we have the lid off of the tower mount amplifier, and you can see all of the sub-components that make it up. Start over here on the power supply section, and it's an AC to DC converter. Takes in 85 to 264 volts AC and converts it to a regulated 28 volts DC for the rest of the system. This power supply is rated at about 1,000 watts, and what makes it interesting compared with the more commonly seen power supplies that you'd see in your PC or similar type of equipment is that it doesn't have a fan internal to the chassis. The reason for this is because when this is out in extreme temperatures, the internal air temperature of the chassis will not support effective cooling of the power supply module. It would overheat. So what this PSU has is a metal base plate that we connect to our heatsink, and that's the way it's cooled. The heat is exchanged with the outside air rather than the inside air of the chassis, which can be done in your PC because it's dealing with lower air temperatures. Moving on to the RF section, once the RF signal comes in through the outside, it first hits the attenuator board, which is SPI controlled and allows the user to adjust the output power of the amplifier for a given input power. The adjustment range is about 20 to 30 dB in about half dB steps. After the signal exits the attenuator, it goes into the pre-driver amplifier and then the output power amplifier. The PA setup in here is about a 200 watt RF power module that operates from about 2 to 2.4 gigs depending on the application. When the RF signal exits the power amp module, it goes into the RF detector and circulator board. And what this does is protects the amp from excess VISWAR or an open load or any bad output condition that's not ideal, but it also measures the forward and reflected power, sends it through an analog to digital converter, which is read by the control board. After that, we have an output filter, cavity type, and it goes out. Our control board here uses a Rabbit microcontroller, which has a nice web interface where we have made a custom web application that controls and monitors the amplifier, and a couple of other things needed by the system. A little bit of onboard memory, some ADCs to read and interpret the various statuses, temperatures of all these individual modules. This controller board over here measures the current of the amplifiers, the fans, turns them on and off when directed to do so by the control board, and basically that's the whole system.